All right, guys. All right, so we are back from the interruption. So Mr. Lamar, are you there yet?
Sir?
All right, are you ready now to walk me through the first one?
Yes, sir.
Okay, so tell me what to do.
So first I can just cancel the b with find b squared and then I get b.
All right, so b in the denominator, b
Yes,
to
sir.
the
Then
power 1, cancel with b to the power 2, only leave what? B.
yes, sir.
And then now what else?
Sir, I can cancel the c.
All right, so c to the power 1 in the numerator.
And c squared at the denominator.
Right. Next.
Can cancel the a's.
All right, so a into itself 1, a into a down here, it's 1. Next.
And sir, I can write it on the right side now. So you have b.
All right, so we only have 1 in the first fraction and b, the second fraction. Multiply those, we get 1 times b. And then now
Over 1. No, sir, over c, over b over c.
So we have c in the first fraction, the denominator, and 1. So c times 1 give you c. All right, good. All right. Everybody get that? Raise your hand. All right. Okay, next, who wants to walk me through the second one? Let me. Mr. Arty, walk us through the second one, please.
Sir, I can cancel the 3. Hold on, David.
What is it? You're canceling this 3?
Sorry, sir, we can cancel the P, Q.
Hold on,
in
Mr. Arty. You were saying something about the 3 first. What are we doing with the 3? Are we canceling?
We can cancel the 3, sir, but we won't have anything in the numerator.
No, but you have 3 in this numerator here and one other 3 in this numerator here. What we don't have anything common with the 3 in the denominators. So it means that if we don't have anything common in the denominator, we cannot cancel. Is that clear, Mr. Arty?
Yes, sir.
Whatever you're canceling in the numerator, you must have something with it common in the denominator. So it doesn't matter which of the denominator, but whatever you're canceling in numerator, it must be canceled with something in one of the denominators. All right, continue then, Mr. Arty. So the 3 cannot be canceled because there's nothing common with 3 in the denominators. So what else can we cancel if there's anything?
We can cancel the Q. Q in the second, in the QS with
So
the Q
we
in
can cancel this Q with
the Q
squared
in
up. Cancel out the 2 here, we have Q left. Anything else?
and we can cancel the R with 3 RS.
Are we finished with the Q yet, Miss Dorothy?
Oh no, sir, we have another. We can cancel again with Q with the Q in.
So this
3P.
Q here can be canceled with the remaining Q down here. All right, so the Q is finished now. What else can we cancel?
No, we can cancel the P with the denominator.
All right, so
And
this
the
here,
numerator.
the numerator and this P down here. What else?
And we can cancel R numerator R with denominator
Right,
R.
so this R with this R here. A second. All right, so this R with this R here. What else?
We can't, no, we can't do that. There's nothing else.
No,
you
no, it's a
can-
joke.
All right, so if there's nothing else to cancel, what else do we need to do now, Ms. Sargent?
So we'll multiply what we have.
So what do we have in the numerator?
3 times 3 is
3 times 3, so you multiply the numbers together, you get what?
9.
So what else we have?
9 is
What about, so you have a S
in the
here,
bottom. Yes, sir.
and you have another S here. Aren't you going to multiply those together? S times S give you what?
Who is
No,
S?
S square.
It's to the second. Yes, sir.
Right, you have to be careful. In the denominator, what do we have?
We have 2t.
All right, so we have only 2t, so it's 9s squared over 2t. All right, is that it? All right, everybody get that one? Raise your hand if you got that one, guys. All right, Ms. Cabrera, are you understanding what we're doing?
Yes, sir.
Okay. You want to help us with the next question then, Ms. Cabrera? Can you do question 3 for us?
I wasn't finished, but yeah.
Or you want to do it?
Yeah, I can do it.
All right, walk me through. So let us start off with the numbers first. Can we cancel any numbers at all?
Yeah, the 6 and the 3.
All right, so 3 into itself goes 1, 3 into 6 goes 2. What else?
5 into the 10.
All right, 5 into itself. 5 into 5, 1, 5 into 10 goes 2. What else? Are we through with all the numbers?
Yes, sir. Through it all of the numbers, I think.
All right, so what we do next?
We cancel the Z.
All right,
in the
Z.
first one. We cancel one of the Z's in the first.
All right, so here we have Z squared in the numerator in the first one, first fraction, and Z in the denominator of the second. So this Z is to the power 1. So we subtract 1 from this square up here, leaving just Z. What else?
Y, you're going to cancel the Y in the first set and leave one.
So Y in the numerator here as the power 1. And then now, when you're canceling the power 1 with Y to the power 2, you subtract 1 from 2, so you just only have left Y down here to the power. All right, next. Anything else?
Yes, sir. The
A
denominator.
in the denominator here to the power 1 with A to the power 2, so you just subtract 1 from here, leave A. Next.
I don't think there's any more to cancel.
You sure about that? Look carefully.
The C's.
All right, so this C squared here. So they are to the same power, so you can cancel them. So C squared cancel with C squared in the numerator. Anything else to be canceled?
No, sir.
All right, so what do we get now in our numerator for the result?
2zy times a times.
All right, remember there's a 2 here too as well. You see this 2 above the 10, don't forget about it, all right?
Yes, sir.
So multiply all that we have in the numerator now. Multiply the numbers first. There's another 2,
Times
there's another 2 here too as well. So what we have now?
would be 2 times 2 equals 2 2's 4, and then 4 times 2 equals 8.
Okay, so the numerator we have 8 for the number. What else now in terms of the symbols?
You have Z, A, yeah, just Z.
So we have Z in the numerator, A in the numerator. All right, so how do we arrange them in the result? Which letter comes first? All right,
A and Z.
so we have A, then Z. All right, what we have now in the denominator?
Plus y squared.
So the denominator we have, what about how much is what we have in the denominator?
Y cube.
All right, so we have y cube only. You don't send a number in the denominator.
No, cause the 3 to 5.
What
Oh,
about
yeah.
this one here?
So it'll be 3y cube.
So we have 3y cube. All right, everybody is good with that. Let me see your hands if you have gotten that one correct. All right, good. All right, now, Miss Green, do you want to do question for us?
Okay, sir. They're going to write 3p squared cube
What next?
times 15s squared over p squared.
All right.
We're going to use 5 to cancel 15. Going to leave 3.
So 5 cancel with 15.
Yes,
So 5
sir.
into itself 1. 5 into 15 goes 3.
Yes, sir. And going to cancel the s with one of the s over s squared.
All right, so this S, so cancel this S with one of the S in the S square, leaving just S.
Sir, p with the p squared
All right, so p squared with p squared.
They're going, I just was the P for the there.
Oh, there shouldn't be any p right here. Sorry about that. All right, so the p here, p to the power 1 cancel with p squared. So we subtract 1 from the power 2, leave just p to the power 1 here. All right, what else?
They're going to say 3 times 3 is 9.
All right, so in the numerator, we have 3 times 3 for the number, give you 9.
Yes, sir. And SQ.
And then we have SQ.
And for the denominator, you're going to write RP.
Right? So we'd have RP down there. Which one come first though, P or R? All right, so P would come first. So let us write it in the alphabetical order. So P, then R. All right, is that clear? Everybody got that? Raise your hand. All right, let's wait some. Mr. Bartley, do you want to try question 5 for us? Mr. Lamar, saying something?
Oh, no, sir. I just did not take them a hand.
Okay. Mr. Bartley, are you there? All right, seems that Mr. Bartley is unable to attend to us. Ms. Waysome, can you walk us through question 5, please?
Yes, sir.
All
All
right,
right.
go ahead.
6AB over 5CD. We invert the second fraction to 7BD. So change the sign.
Give me a second. So 6AB
Over 5CD. Change the sign to multiplication. And then invert the second fraction. 7BD over 4A squared.
All right, so 7BD
BD over 4A squared.
All right.
With the numbers,
what to do?
all right, with the numbers now, sir. 4 and 6 can be cancelled by 2. So 2 into 4 goes 2 times. And 2 into 6 goes 3 times. So we're through with the numbers now. So A into A squared would leave us with A.
All right, A cancel with A square.
Leave us with A. And then B cancel with D, sir. Yes, sir. So we would now have for the answer 7 times 3 is 21. And the B times B give you B squared. And over 5 times 2 is 10. And then A times C is AC. So 10 AC.
All right, guys. Anybody else got this? Raise your hand for it, please. All right, good. All right, guys. So everybody is good with this. So I'm going to move on. You're going to I'm going to move on from here. So let me clear this and move on, guys. All right. What we're going to be looking at next, we're still on multiplying fractions, but now if you notice the fractions that we have just looked at, these fractions are fractions with just simple terms in their numerator and denominator. So these are just terms in the numerator and denominator. But we're going to be now looking at fractions with expressions in both numerator and denominator. And before I start looking at an example, can anybody remind me of what the difference is between terms and expression? Nobody can tell me what's the difference between a term and an expression? Ms. Waysome, what's the difference between a term and an expression?
I don't remember.
Ms. Green, terms and expression, what's the difference?
Term are just like AX and then the expression was additions.
All right. So whereas terms can be simple, the product of numbers with letters, or just a number by itself, or just a letter by itself, we have expressions which has to do with adding and subtracting of, unlike terms. So when you have unlike terms being added or subtracted, you will get expressions, all right? So we'll now be looking at some fractions where we have expressions both in the numerators and the denominators. So these are some things that you have to bear in mind. Now, so expressions in brackets may be regarded as a single term. So when you see a bracketed expression, you treat it in the same way as you would treat a single term. Now, from in the previous questions, we have been canceling like terms, like cancel A with an A. But in this case, we may see expressions. So what we can do is to cancel like expression. So we can cancel an expression in the numerator that is the same as an expression in the denominator. All right, so that is one thing to bear in mind. The next thing to bear in mind, now if we have expressions in the numerator and denominator, one of the things that we want to do is to check to see if those expressions can be factorized, because we want to factorize them first before we do any form of canceling. So factorization must be done on the expression before you cancel. And please note that, guys, because sometimes students will make mistakes in their cancellation if they don't do that. All right. So cancellation with common factors both in the numerator and denominator should be done after factorization. So please follow that order. Do factorization first, then you cancel. All right, here's our first example of fractions where you have this is our fraction with expression in our numerator and denominator. Now this is one single fraction. Now we are not multiplying anything, any fraction by any fraction here. But what we want to do first is to see if we can simplify this fraction by either canceling anything that we see in the numerator and the denominator. But if you just listen to what I said first, what should be done first?
So we're going to look for common terms to cancel first.
So remember, just now I had mentioned that we should do what? Before we cancel. What should we do before we cancel? All right, now this is a common error, common mistake that students will make. They will look at an X down here and say, X down here cancel with an X. Or if you want, you might take X cancel with an X here. Or in some cases, you might say X cancel with an X here, and you have that. Now that is incorrect. Don't do that, guys, because it is an illegal thing, very illegal. When you try to cancel a term out of one expression with another term in another expression, you cannot do that. And that is the reason why in the first things that we note, going back to that slide so that you get it clearly. So here, the first thing that we note is that you treat expression as a single term. So if you're treating an expression as a single term, it means that you cannot take part out of one expression and cancel it with part out of another expression. You cannot do that. The entire expression has to be treated as one. So because of that, it is illegal to cancel one part of an expression with another part of another expression. Is that clear, guys? Is that clear, Ms. Waysam?
Sir?
Yes, sir, it's clear.
All right.
Sir, can you repeat, please?
So I was saying to you just now is that whereas we have expressions, wherever we have expressions in fraction, we don't treat expression, all right, in other words, we treat an expression as a single term. So if this is a single term, you cannot alter it in the sense by canceling part of it with part of another expression. You follow what I'm saying? So because everything in this bracket is considered one thing, so you can go in and just cut out part of the X and left the Y. Because it would no longer mean that you're treating it as one. So to treat it as one, you have to take it that it cannot change once it is in brackets. You follow what I'm saying, Ms. Waysam?
Yes, sir.
And so when we know, if you look in the numerator here, this is an expression, and in the denominator, that's another expression. So we can cancel an X out of the denominator with an X in the numerator, because in that sense, we would not be treating each expression as a single unit. Once it is by itself as an expression, it is a single unit, and you have to treat it as a single unit. So the first thing that you want to do here is to look at your expressions, both in the numerators and the denominators, and to see whether or not any of these expressions can be factorized. So if you have any that can be factorized, you factorize it. So in this case, can we factorize any of these expressions? Can we factorize the one in the numerator or the one in the denominator?
The one in the numerator, sir.
All right, so we go ahead and factorize. When you factorize the one in the numerator, what do we get?
X,
All right, so X as our common factor, then what?
open brackets, X minus 1.
So we would have X minus 1. Now, once we factorize it, we just write it back as a numerator, put it back over the denominator. Now, what you notice here is that in the denominator, you have an expression X minus 1. Now, if you want to put a bracket around it to show that it is one thing, there's nothing wrong with that. So now what we see is that we have a X minus 1 in the denominator, and we have a X minus 1 in the numerator, and these expressions are the same. They are exactly the same. So because of that, we are treating them as a single term, and we are going to cancel them. So X minus 1, let me change that color. So X minus 1 in the numerator will be canceled with X minus 1 in the denominator. Now, once you have done that cancellation, then what we have remaining in the numerator is just X, and in the denominator would be 1, which would just give you X. Is that clear, guys?
Okay.
All right. So that's the approach to these questions. All right, so with that said, let us continue. So here we would have our results where we factorize the numerators and the denominators, and then we cancel, and then what remains we write. All right. All right, moving to the next example. Now here we have two fractions that are multiplying together. Well, each of these fractions have expression both in the numerators and the denominator. So what do we need to do here now, guys? What do we need to do? First step is to do what? Ms. Green?
Factorize, sir.
Right, so wherever possible, factorize whatever expressions can be factorized. So what are the expressions that can be factorized here now?
3x minus 12, sir.
All right, so what else?
And we can factorize 4x squared minus 8 as well. All of them, sir, as far as we see.
All right, so tell us what you would get if you factorize the numerator of the first fraction.
We would have a 3, and then x, open brackets, sir, x minus 4.
And so what if we factorize the denominator, we get?
We get 4, sir, open brackets, x squared minus 2.
All right, so we can put back our multiplication sign here.
Yes, sir.
For the next fraction now we'll have what?
2, open bracket, x squared minus 2.
For the denominator?
9, sir. X minus 4.
All right, so now that we have factorized both numerators and denominators, can we cancel anything?
Yes, sir.
We're canceling numbers first. and then cancel expressions after. So in terms of the numbers, what can be canceled? Well, I saw Miss Waysome, I guess she dropped off a while ago. Miss Waysome, are you back now? I guess she's connecting. Miss Waysome, are you there? Are you back now, Miss Waysome?
Yes, sir.
All right, so continue with the process. Tell me what we can do.
All
What can
right,
we
sir.
cancel?
So, 3 into 9. So 3 can cancel with the 9, sir. So 3 into 3, 1. And then 3 into 9 goes 3 times. And then 2 into 2, 1. And 2 into 4 goes 2 times.
All right. What about the expression?
Yes, sir. X minus 4 can cancel with X minus 4. And X squared minus 2 cancel with X squared minus 2.
All right, so what we have remaining in the numerator?
In the numerator, 1.
So 1 times 1 give you 1.
And 2 times 3 is 6 in the denominator, sir.
Okay, good. All right, is everybody clear on that? Raise your hand if you understand what to do. All right, good. All right, so we'll move on. So factorize our numerators and denominators, and then we cancel. So answer would be 1/6 for this one. All right. Here we have another single fraction. This is not multiplying by anyone, other fraction, but they're asking you to simplify it. Now remember, in order to simplify a fraction, you want to cancel what you can cancel both in numerators and denominators. But for algebraic fractions, before you can cancel anything, if you have expressions, you have to factorize the expressions both in the numerators and the denominator. So in this case, guys, can we factorize the numerator and denominator in this case?
Or maybe just the denominator.
And can the numerator be factorized, or can the denominator?
Just the denominator, sir, I think.
All right, anybody else agrees with Ms. Waysome? Raise your hand.